Hello and welcome to the second part of our chemistry math lesson. This video is about unit conversions. I'm going to go through the introduction with you, which includes a couple examples, and then there will also be a help video directly tied to the packet that you have for your work. So look for 2 videos on the subject. Plus, we'll discuss this in your cohort classes in week 3. So next week from when I'm filming this right now. All right, so I'm going to talk about unit conversions, and I'm going to teach you a method that will always work for converting one unit to another, whether it's a metric unit or whether it's another kind of unit. We're going to use this method for a particular type of problem in the second semester, but you can use it across a broad range of problems during the course. And we'll review this unit and develop your skills with it through the entire first semester to make sure that you're ready to do this when you need it in the second semester. All right, so we're talking about converting units. Right? So when we talk about unit conversions, when students say they struggle with them, normally it's because they're not familiar enough with the units themselves rather than the process of converting. You can convert units when you are very comfortable with the unit. So take, for example, money, right? 400 pennies, right? How many nickels would that be? Well, you know that there are 5 pennies in a nickel, so you divide by 5, okay? Be 80. Okay. How many dimes would that be? Be 40, okay, because 400 divided by 10. How many quarters would it be? How many dollars? That's obviously the very easy one, okay? So when we're talking about why we convert units, in addition to how we convert units, think about the different types of money, right? Conversion is for convenience, right? You carry $4 bills instead of 400 pennies because it's easier, because it's more convenient, and because it suits the task that you have for the money. And the same thing will be true when we convert units. We convert one unit to another because we need a more convenient unit, or a unit that suits the task that we're doing. And also the last question here, did the total amount of money change? No, 400 pennies is the same amount of money as $4. So when we're converting units, the actual value of the original measurement doesn't change. It's just the unit that we're using to express it. So we have the same amount, we just are using a different unit to describe that amount. Right? So that gives us our reasons. More specific reasons, though, instead of the broad ones that we just discussed. We convert because we need a bigger unit or a smaller unit to make the number more convenient. This is a really underrated reason why we convert units. If you're using the wrong unit, then the number that you're going to be using is going to be inconvenient for you. If the unit is too small for the job that you're doing, then the number is going to be very large. If the unit is too large, then the number is going to be very small. And either way, it makes the numbers more difficult to work with, difficult to write, difficult to include in calculations. If you use the correct unit, then you get a convenient number that you can handle more easily. It's easier to put into your typewriter or into your typewriter, and it's easier to write it down as you're working on a problem by hand. The other reason why we often convert units is because a certain unit is required in a problem. And there are whole types of problems where there are certain units that are required. For example, in our third unit, there's a type of problem where the volume has to be in liters, or where the temperature has to be in kelvins. And so that means that we're going to convert the unit first before we can actually do the problem. We need to make sure that the numbers are in the right format, in the right unit to solve. The method that we're going to use to solve these is called the factor label method, and it's a simple 3-step process, but the details can be a little bit difficult to pick up for some people, and so it takes a little bit of practice, a little bit of rehearsal. But the simple 3 steps to remember are: step 1, copy the original number that you're working with its unit. This is the number that you want to convert to a different unit. Right, so I'm going to copy that down. In a lot of problems, there is only one number, so you really don't have a problem knowing where to start. You start by copying the one number that's in the problem, and make sure that you copy the unit. Right, the second part is where the skill begins to be developed, and that's what we're going to practice today. Write a conversion factor, and I'll show you what that means, so that the old unit, the one that you don't want, will be canceled out, and then we can substitute in the new unit. When we write that conversion factor, we're going to be putting values in there that are equivalent. You'll see what I mean in just a minute. where the values go depends on where the units are. Right? And so then once you have everything set up correctly, you have your original number with its unit, and you have your conversion factor with its values and its units in it. Then you simply look at it, and I'm going to take my original number and multiply by anything that's on the top of the conversion factor, and I'm going to divide by anything that's on the bottom. And if you do that step by step, and you don't skip any steps, you label everything, which is why it's called the factor label method, then you can get through any problem, and the math at the end can be relatively straightforward for you. All right, so writing a conversion factor is what we want to practice today. A conversion factor is a comparison between two different units, and they need to be equivalent. It's important to understand that I'm not saying equal in this case. They're not going to be numerically equal. They're two different values for the same measurement in different units. So they're not the same number, but they represent the same quantity, the same amount of whatever it is that we're measuring. So an example of that would be that a yard is the same as 3 feet. Right? So 1 is not equal to 3 mathematically, numerically, but 1 yard is equivalent to 3 feet. They represent the same distance or the same length. Right? In the same way, we could say that 1,000 milligrams are equivalent to 1 gram. And again, they're not numerically equal, but they represent the same mass. 1,000 milligrams and 1 gram are the same quantity of matter, which is something we'll also talk about down the line in this course. Right? And so we need two values that are equivalent. They represent the same amount in different units. Right? And then we write that as a fraction. So we take those two values, and one goes on the top and one goes on the bottom. Right? And because they're equivalent, we can write it either way. So I can put, milligrams on the top and grams on the bottom in my previous example. But the conversion factor is actually just as valid if I put grams on the top and milligrams on the bottom. I'll show you all this in example form in just a minute. But that leaves the question of how do I know which one goes on top and which one goes on the bottom? And that's where the label part comes in. So this is factor, which is a conversion factor, and label, which means labeling your units. And if you label your units and if you learn how to write a conversion factor, then everything is good to go the rest of the way. It's just a matter of applying the steps in the correct order. All right, so let's do an example here. This one's on the screen, and then we're going to work a few on the whiteboard as well as we go through these notes. All right, so we're going to write a conversion factor to convert between pennies and nickels. All right, so the equivalent values, as you know, 5 pennies are equivalent to 1 nickel. Okay, and so I can write that as a fraction. So I put 5 pennies over 1 nickel. That's one way to write this conversion factor. It's just as valid if I flip it over. 1 nickel is equivalent to 5 pennies. Right? And so the version of this fraction that I use, one has pennies on top, the other has pennies on the bottom. The version depends on what I need to do in the problem. It depends on what my original number is. What is my original unit that I'm trying to get rid of? And I'll show you how to work that out right now. All right, so we're going to convert 5 days into hours. Okay, so over here on my little whiteboard, we're going to start by copying the number that we're given, 5 days. I'm going to use D to represent days just to save a little bit of space here. All right, and then I'm going to write a conversion factor. Remember, the conversion factor is a fraction, right? And sometimes we need more than one conversion factor. So I'm going to put my fraction in parentheses. That way it protects that conversion factor, and it gives me a visual for each step. Each step is a set of parentheses in our calculation. Right? In this particular case, we don't need more than one step, but I'll show you a couple examples where we do. All right, so 5 days, and I'm going to write a fraction here. We're going to multiply our original number by this fraction, by this conversion factor. All right, it's important to understand that we're multiplying them. They're put side by side to indicate multiplication. Right, and in this conversion factor, I need equivalent values for days and hours. Right, so 1 day is equivalent to 24 hours. Right, and so the question is, which one goes on top and which one goes on the bottom? And that's where the rule comes in for this. I said, set up your conversion factor so that the original unit will cancel out. Right, so if I'm starting with days, then I want to put days on the bottom of my fraction. And then if I'm finding hours, I want to put hours on the top. And again, I'm putting it on the bottom because I want to cancel that out. Okay? It won't always go on the bottom because I'll show you an example in just a minute where it doesn't. But it goes in position to cancel out, which most often is on the bottom. The original unit usually goes on the bottom of the fraction because that's where it needs to go to cancel out. Now, I've put the units in first. This is a habit that I will always follow when I work this type of problem, and I recommend you get in the habit too. Set your units up first before you fill in any numbers, because the units are like the map to the problem. When you write out these conversion factors with the units, it's like sketching out the framework of the problem. Make sure that you have the right path before you begin your calculations. All right, so now I'll fill in the values. 24 hours are equivalent to 1 day. And I'm going to cancel out my old unit, which indicates to me that I only have hours now. The days have been removed from this expression, and my result is now going to be in hours. Right? So because that is on top of the fraction, the number 24, right? That means I'm going to multiply them. Notice again, they're adjacent to each other, which implies multiplication. 5 times 24, okay? 120, so no, sorry, 30, 140. My math deserted me for just a minute there. All right, 140 is the number there. No, that's not right. All right, so that equals 120 hours. Right? And I realize that many of you could get there without this full setup. I understand that. That's not really the point of what we're doing here. I want you to practice this in a context in which you're familiar with it, when it's easy, in other words, so that you can use this factor label method when we get into more difficult applications later on. Okay? So let's talk a little bit about what happens if you need more than one step. Sometimes you can't get directly to a particular answer with only one conversion, usually because you don't know what the conversion is. You don't know a direct equivalence between those two things. And so you have to convert into an intermediate unit that you are familiar with in order to move through. And then sometimes there's more than one unit to convert, which also leads to more than one step as well. And so let's talk about how we set those problems up. Right? And I'm going to go through and show you a couple of different ways to approach this, but there definitely is one that's more efficient and economical in terms of space and effort, and that's the one that I'm going to be emphasizing as we go forward. Right? As I just mentioned, some numbers have multiple or compound units. Example of compound units, when we divided mass by volume in your measurement lab, right? So that would be grams divided by milliliters. That's the unit, grams per milliliter. So there's actually two terms in the unit. Miles per hour would be another example. In physics, there's all kinds of combined units that simply come from multiplying and dividing different terms with different units. And so when you have a compound unit, it's possible that you may need to change more than one term within that. So for example, if I want to turn miles per hour into the metric equivalent, which is meters per second, then I'm going to have to turn miles into meters, and I have to turn hours into seconds. So there's multiple steps that are involved there. All right, so I'm going to do a couple of examples here, and I'm going to particularly show you how to work with metric prefixes, since a lot of people struggle with mentally converting in the metric system, and I want to talk about how we can use this factor label method to make that easier for you. So let's start with this example, 85 centimeters. And over on the right-hand side over here, I want to get kilometers. So that's my goal. Right? Sometimes I will put my target unit out there as a little bit of a reminder for me. All right, so copy the number that you're given with its unit. That's step one. Step two is to make a conversion factor. And I always put my conversion factors in parentheses, although there are different ways to write these that you can find if you look out on the internet, for example. Some people make boxes. There's a couple of different ways to do this. Some people write fractions with a little times symbol between them. Any of those options are okay. All right, I do not know how many centimeters there are in a kilometer. All right, so instead what I'm going to do is I'm going to convert centimeters to meters. That's something I do know. I do have a value for that. All right, and so then I'm going to change my meters into kilometers with the second step over there. All right, so let me show you those two steps separately. All right, so there's a couple different ways we can do this. All right, I can say that 1 centimeter or 1 meter is equal to 100 centimeters. That would probably be the simplest way for us to write that. If you don't remember that, though, you could always go onto your reference tables where we have a list of these metric prefixes and their values. And you can find that centimeter means 10 to the minus 2 meters. That's another way that we could write this. If you know your powers of 10, you know that 10 to the minus 2 is 1/100, so that's exactly the same as the previous way. Right? So you can fill in the powers of 10 on those. I find, though, that it's easier for people to use the straight value rather than the power of 10 value for these. All right, so when I set this up, I put centimeters on the bottom because I want that to cancel out. Meters are on the top because that's what I'm trying to find right now, even though there's still one more step yet to go. All right, and since the numbers tell me there's a 1 on the top and 100 on the bottom, all right, so I'm 85 times 1, which I don't have to do because 1 is, or anything times 1 is itself, and then divided by 100 because it's on the bottom. So 85 divided by 100 is 0.85 meters. Okay, but that's not my answer because I need kilometers. So I'm going to take that number and I'm going to make a second conversion. I'm going to put meters on the bottom because I want that to cancel out, and I'm going to put kilometers on the top. And again, the reason why I use meters is because that's what all the prefixes are defined in terms of. They're all defined in terms of the base unit that has no prefix. Right? And so by doing this, I can find the values if I don't remember them. I can look them up, and then it works out quite nicely. All right, so 1 kilometer means 1,000 meters. That's what kilo means, 1,000. Right? And so these the top and bottom are the same. 1 kilometer, 1,000 meters means the same thing. And again, meters is going to cancel out. And therefore, 0.85 times 1, which we don't have to do, and then that answer divided by 1,000, I'm going to get 0.00085. Okay? And so that's an example of 2 conversions. Now, I don't have to separate those, and that actually takes up more space than I need to, because I can actually put the second conversion right here. Right? So 1 kilometer is the same as 1,000 meters. Because we're multiplying by these fractions, we can stack them together into a string. Multiplication works really well for stringing the different steps together. Right? And so as I go through here, ignoring the ones because the ones don't change anything when we multiply or divide by them. 85 divided by 100, and I would hit equals in my calculator. And then that answer divided by 1,000, and you'll go through and you'll get the same number. Okay? All right, so that's an example of a 2-step calculation, which you can do with any of the metric units and their prefixes. And I got one more example for you here to work, and then I'm going to record a separate video with some specific problems from your packet so that you can have a few examples to fill in and follow when you go through there. All right, so we're going to talk about a speed. I've been making references to speed sometimes, typically with miles per hour, but this is meters per second, right? That's the unit, and this is how we tend to write them when we're talking about a multiple unit with a slash like that. But I want you to understand that what that really means, 55 meters per second means 55 meters per 1 second. Okay, that's the same thing. And when you write it this way, it's a lot easier for you to see what you need to do in order to convert the units. Right? So whenever we see per, like miles per hour, meters per second, grams per milliliter, right? We want to put that into a formal fraction format. Right? So that's the number that I was given, 55 meters per 1 second, or 55 meters per second. And now I'm going to make my conversions. Right? So the first conversion that I need to make, we're supposed to turn meters to kilometers. So I'm going to do that first. I'm going to put meters on the bottom, kilometers on the top. And again, as we know, 1 kilometer is 1,000 meters because that's what kilo means. And that cancels out the meters right there. I'm not going to calculate yet. I'm going to make my second conversion factor. And this time I want to get rid of seconds. Right? We're asked to turn seconds into hours, which I can actually do directly, but if you don't remember the conversion, you could do seconds to minutes and then turn minutes to hours. So you can always break bigger conversions into smaller steps if you need to. So I'm going to turn this into hours. Now notice I put seconds on the top here. This is the one that I'm canceling out because it starts out on the bottom of the fraction. And that's why I want to make sure that you know that the rule isn't take the starting unit and always put it on the bottom of the fraction. The rule is take the starting unit and put it where it will cancel out. If meters is on the top, it will go on the bottom to cancel out. But seconds is on the bottom of the original unit, so it goes on the top to cancel out. And there are 3,600 seconds in 1 hour, right? Or 60 times 60 if you want to shorten the math right there. And then you can go through and make the calculation from there. Right, 55 divided by 1,000, then that answer times 3,600. And again, I can't emphasize this enough because this happens a lot in the course. Right, when we look through these conversion factors, right, you ignore the ones because nothing happens when you multiply or divide by 1. And then I find the other numbers. If that number is in the denominator, it means divide by that. And if it's in the numerator, it means multiply by that. You don't have to do them in order, but I typically do. And I always do one step at a time, and I always hit enter in my calculator, or equal in my calculator, after each step, so after each parentheses that I do. So it'd be 55 divided by 1,000 equals, and then take that answer and multiply by 3,600 to get the final result there. Right, so that's what we've got in terms of an introduction to factor label. Like many things, though, the more you work on it, the more comfortable it becomes. So even if you're not 100% clear or not, you feel like you're not clear at all on this, don't be afraid to wade into the work and try it and see if you can figure it out. You will have keys available so you can look at them to find your mistakes and continue to learn as you go forward. And I will produce a second video that has some more examples for you to look at, reference, and follow.